Welcome back to another exam walkthrough. I've got here another paper. This is going to be from 2024 October Unit 2, question number 8, 10, and 15. All right, let's start with the first question. It says a student connects 4 resistors between X and Y as shown, and they're asking us for the total resistance. So here we have in series, here we have in parallel, and here we have a short circuit. So how do you identify short circuit? Is that in a short circuit, what's going to happen is that one side you will have the component connected, a resistor, and the other side will have no resistance. Now the current prefers the path with the least resistance. Here the resistance is 0. Here the resistance is, comparing to 0, it's a lot. So all of the current will just flow through the 0 resistance side. Okay, so they'll flow through the 0 resistance side. So hence, when you have short circuit, the resistance is just 0. Okay, so we'll just ignore this. So again, the key identifier is you will have a component and then you'll have nothing connected next to it. And another example of short circuit is a battery with nothing connected. Okay, and this is again dangerous scenario because you have a lot of current passing through and it can cause fire as well. Okay, so now we can do 15 plus the resistance of these. So 1 over R total is equals to 1 over R1 plus 1 over R2. Okay, and that's going to give me 1 by R total is equals to 1 by 7 plus 1 by 18. And then I can just flip both sides. So I'm going to get R total is equals to 1 over 1 by 7 plus 1 by 18. So 1 over, and we just inverse it basically, right? So this is going to be the resistance total of these two. Okay, basically I'm doing this with both of the sides. And then we can just write 15 plus that. So let's just grab that. And that matches option number C. So hope this is clear. Parallel resistance, short circuit, series. Short circuit has no resistance, remember that. Okay, next question we have is a circuit shows a cell connected to 2 resistors. The cell has negligible internal resistance, and they're asking us the power transferred by the 20 ohm resistor. We know power is equals to IV, and the current coming in and current going out is going to be the same. And since they're also in series, we can use V total is equals to I and then R total, and then I can just substitute the values in, and this is the value of the current. Then to find the potential difference across the 20 ohm resistor, I'm going to take the current times the resistance of the 20 ohm resistor, and I'm just going to plug the values in, and then I'm going to take both the potential difference and the current, and I'm going to put them side by side because power is equals to this is going to be I and this is going to be V, so IV. Okay, and the expression that matches this is gonna be number C. Okay, so if that's clear. Okay, let's move on to the next question. Right, so next question is a strain gauge is an electrical instrument that can be attached to an object to measure mechanical strain. The strain gauge has 6 metal strips attached to the small piece of insulating material. The metal strips are joined together by connectors. The initial length is going to be 18 millimeters. Okay, and then they've given you that the cross-sectional, the rectangular cross-section has a width and a thickness of those values, and the resistance between the terminals is going to be 0.16 ohms. And then we have determined the resistivity. So our diagram will look something like that, where we will have this right over here, our thickness, our width, and then our length right over there. Okay, and we have like this, we have 6 total metal strips. Okay, and then they have given you the resistance of 0.16 between the terminals. So let's just do this real quick. So we're gonna have the formula. The resistance is equals to P rho L over A. The cross-sectional area is going to be the width times the thickness, okay, and our total length traveled is going to be 6 times the length that the current will travel through in one metal strip. So the total length will be 6 times of that because we have 6 metal strips. So unplug the values, and before I even do that, let me make rho the subject. So rho is equals to r, then thickness and width divided by 6L. This is the total length. That's going to give me the rho value. And the answer is going to be 4.77 times 10 to the power of minus 7 ohm meter. Now, why do we take 6L here? Now remember, this is the potential, this is the resistance between the terminals. So the resistance value we have here, okay, the resistance between the terminals is the resistance that is there due to the 6 metal strips, okay. And what I'm trying to show you here is that we have this cross-sectional area which we found out before, and here we have 18 millimeter, and then this is 1, then we have another 18 millimeter, and so on. So we have 6 of them. So I'm gonna write, if 1 is L, then the total should be 6L, right? You're gonna add 1, 2, 3, 4, 5, 6, so you can just write 6L. Okay, so this, all of these, when the distance increases, when you add 18 plus 18 plus 18 plus 18, the length will increase, right? So due to this 6L, or this 18 plus 18 plus 18, 6 of these, the resistance that we get due to all of these is going to be 0.16 ohms. Okay, that's why we use 6L here. Okay, and then we get this as the answer. Remember the units, ohm meter. Okay, next is going to be the strain gauge. The strain gauge is stretched and the length L of the metal strips increases. Okay, so the length increases, and then it says the metal strips change the shape uniformly along their length. Okay, explain why the resistance of the strain gauge against L square would be a straight line. Assume that the temperature is constant and the volume remains the same. Okay, they've given us a good hint here. These are really good hints. Okay, so first let me just write the equations down. So we have resistance is equals to rho L over A, and then we know volume is equals to area times length, and then volume divided by length is equals to area. The hint that I'm getting is this: volume of each metal strip is constant. This is my hint right over here. And then we can say that R is equals to rho L V over L. So R is equals to rho L square over V. Okay, so then we get this, and then we can say R is equals to rho over V L square, Y is equals to mx. If we plot this graph, we get a straight line, R against L squared. So they both are directly proportional, and we get a straight line through the origin as well, where the gradient is rho over V. Now, how would you write the answer? Let me just write the answer down. So here's the answer. The cross-sectional area is volume over length. As the resistance is this would change the formula to resistance as rho L square over V, which has a straight graph of straight line through the origin and shows that R is proportional to L square. That's why the graph of this gives you a straight line, is because they're proportional, directly proportional to each other. Okay, so that's going to be the answer to these questions. I'll show the marking scheme and the examiner report as well.